Hello, welcome to Robotics and AI for supporting first response services. My name is Caroline Tribelushi, and I'm a lead AI at KTN. We will have 3 speakers in this session today. The first one will be Paul Gowans, who is from Scottish Ambulance Services, and then John Tapsfield from a company called Brandwidth, and then Steve Mcclendon, a retired first responder who has led several innovation initiatives in the fire services. Please note that there will be no Q&A in this session, but all the speakers will be in the collaboration session, and that is where you can ask all the questions and also network with other people. This session will be led by Professor Hong-Yang Hu, who works in the Edinburgh University, and also he is a lead researcher in this particular sector of robotics and AI first responders. So before I welcome our first speaker, I would like to give you a summary about this session. When we mention first responders, we mean the first individuals to arrive at any emergency. This includes, for example, law enforcement, paramedics, firefighters, and other people like even volunteers and members of public who will be at the scene. The individuals who deliver these type of services are required to be fast, efficient, and also make immediate decision. And all this with very limited technology support. So the aim of this session today is to highlight and develop awareness about the needs for this sector to funding bodies and investors, research and robotics and AI community, and the government officials as well. First responders' job is quite stressful, let's face it. They don't go and give this service to people who are smiling and happy. They go and give service to people who are extremely distressed. And some incidents are both mentally and physically tough to those delivering them. And when it happens that they have to make very, very quick decisions, fast decisions and accurate decisions, it becomes much, much difficult. So what I'm trying to say here is that let's work together to develop technology solutions which can reduce their stress and also allow them to save more lives. And with this in mind, I will want to welcome Paul Gowans from Scottish Ambulance Services to share his experience in this area. Welcome, Paul.
Hi, everybody. So my name is Paul Gowans, and I really thank you for the opportunity to present here today. What I'm hoping to do is give a bit of an outline about the Scottish Ambulance Service and our approach to innovation, and a bit of a plea really about maybe how you can help us moving forward. So as I said, my name is Paul Gowans. I'm the consultant paramedic at the Scottish Ambulance Service and the Programme Director for Innovation. As a consultant paramedic, I have 4 main portfolios that I have to look after. I still maintain clinical practice, which is really important because any innovations that we have within the Scottish Ambulance Service ultimately need to benefit the patients. I have a senior management role, so I interact on a daily basis with the executive team and the board as it's a strategic priority. I'm involved in education, and I think from an innovation point of view, there are a number of fields when we talk about immersive education roles that we will be able to look at. And I also have a responsibility for research. The Scottish Ambulance Service is a large service. It's the national ambulance service in Scotland with over 5,000 staff. We have over 1,200 paramedics and a large number of ambulance technicians, ACC staff, that's our ambulance control centres, and other support services, all focused about looking after patients. We have a number of territorial boards, and our ambulance stations are spread over 150 locations, with over 650 vehicles within our fleet, all with some IT infrastructure. Things like airwave radio, and also a number of ICT platforms built within the vehicle. RAI Ambulance does over 5,000 missions a year, and we have over 1,000 volunteers. However, when we talk about innovation, we're not starting from scratch. We're building our strategic intent, which was launched last year, which is about pulling research, development, and innovation together, moving forward for the benefit of patients. And our approach to that is very much working with the quadruple helix. We want to work with academic partners, our users, which is staff, patients, other health service professionals, and indeed other emergency services, other ambulance services, and indeed I would extend that to other emergency service partners. We work on a daily basis with colleagues in Police Scotland and Fire Scotland, and working closer together is really important. And then industry. I think for a short amount of time, there's been thoughts that ambulance services or health service work with industry is almost a bit taboo. But industry can have the solutions to some of the problems we face. The Scottish Ambulance Service has recently carried out its risk appetite at board level. And the risk we were most open to was trying new things and using innovation and research to get solutions. This has been signed up for at the highest level within our organisation. So let's talk a bit about the differences. Service development. We already have ambulance response bags. We have to carry a lot of equipment to our patients, and looking at new ways to do that would be a development. We're a research-ready organisation with a good history and many published papers in peer-reviewed journals about the work we've done within the Scottish Ambulance Service. So if we need to do the research, we can either commission that, or we hope to build the capacity in-house. But let's talk about innovation and the challenges we're looking at the moment and the problems we're trying to solve. We're looking at using artificial intelligence, machine learning, and robotics and drones to help us with some of these problems, and I'll just touch on those. Ambulance control rooms get very busy, and on occasions we can have what we call surge demand. What we're doing is working with other partners to look at artificial intelligence and machine learning to have a bot report to automate some of the functions in the control room at our busiest times. Again, we can have some challenges in working in austere environments. For example, there may be large amounts of equipment that need to be moved in a major incident, or indeed in specific incidents, it could actually be quite challenging to put in our paramedics to what would be a non-permissive environment. Or we might just need intelligence from within an environment, and looking at things like robots and robotics to work in those dangerous environments, either due to the atmosphere or what's going on, whether that be a terrorist or chemical incident, for example. The Scottish Ambulance Service has been lucky enough to be working with Napier University looking at some of those solutions. So what will the future like for the Scottish Ambulance Service? The honest answer is we don't know. I've been in the ambulance service for 31 years, and we don't recognise now what it was like when I joined. The idea of key communication between emergency services, or indeed from a single patient at the scene back to our ambulance control rooms or experts within the field to give information to the paramedics at the scene, is something that's often talked about. Ensuring that the paramedic is able to use their hands, for want of a better term, in contact with the patient and working in a touchless environment, again, is something we've all heard the terms around Google Glasses, etc. I hope I've been able to let you know in those couple of minutes about the Scottish Ambulance Service, the size, the challenges we have, and our openness to work with you to try and get some solutions to what are problems, not just for the Scottish Ambulance Service, but ambulance services globally. So as I've said, one of the key things is our interaction with our other emergency partners. And how do we share our information with them going forward? So when we work together, the incident can often be chaotic. And as we get a feel of what's happening, that passage of information and that shared decision making, that shared mental model is really important. So one of the key challenges is how the ambulance service get information. How can we share it with our partners, with the police, with the fire service? This is a real challenge. The only real equipment we have at the moment that is truly interoperable is our radio system. What we need is new systems and joint systems that can ensure that information can be shared two ways, not just from the ambulance service to police and fire, but from colleagues in fire and police to us. That will ensure we get the right resources, and also we have a joint approach to where patients and casualties could end up being sent. So thanks again for the opportunity. I've really enjoyed presenting to you today, and please join us in the collaboration session, which is straight after this, so we can take the conversation further. Many thanks.
Thank you very much, Paul, for sharing your experience, and your challenges are really huge opportunities for robotics and AI in this particular sector. So please wait and understand more about this, or go to the collaboration session to try to understand more from Paul. I will now welcome John Tapsfield from Brandwidth.
Good morning, my name's John Tapsfield. I'm Senior Product Manager at Brandwidth, and I'm here to talk to you about Command AR. Command AR was our response to the SBRI developing instantly deployable infrastructure-free tracking of firefighters' operational incidents. We began by reverse engineering the AR of smartphones in order to create a facsimile from which we could then perform a wide array of experiments with the fire service to ascertain what good enough tracking looks like, and also how these systems would perform in denied, intermittent, low bandwidth environments. So actually varying the update rates, removing data, and experimenting as well with what happens with things like accumulated drift on IMU solutions, as well as sort of SLAM failure. And it's a very, very diverse and complex challenge. There's an awful lot of crossover with robotics in particular as well, thinking about some of the complexities of running robotics on fairly lightweight systems where, say, for example, a 2D sensor might be acceptable. Well, actually, some of those 2D and 3D conversations are directly relevant to us because any sufficiently sophisticated system, if it's generating too much heat inside of a sealed container to survive the environment, is going to fail. So there's lots of trade-offs immediately from the offset, as well as lots of considerations about what the sensor can perceive versus what it can actually issue out, and what it might be able to communicate to another module in very close proximity via, say, Bluetooth or another equivalent device. So the primary goal, however, ultimately is to provide that at a glance understanding, particularly to the fire commander or Baker officer. So in the demo that we're showing, one of our team was instructed to sort of go and map a stairwell. So he took the initiative and actually went downstairs into the basement first to map it from the basement up. And what that meant is that any rescue team that was sent in would have retraced his steps, and since he was tasked to go upwards, might have taken the initiative to go straight up. Additionally, how much information do we need to know to vector to get to that basement, because RF would have cut out at some point. So you've got all these different competing information needs to inform behaviors outside, and that very much ties into an AI ML model about what to send, but also almost sort of a pace approach to situational awareness. ultimately, the other big constraint, other than bandwidth and carried compute and cost and heat proofing and so on, is to think a bit about the cognitive overheads of this information. That the moment you're then starting to provide uncertainty, you're creating a greater overhead. So how do you balance those things? Obviously, AR kind of creates a hands-free environment, and most importantly, it allows you to compare the built environment that's in front of you with the perception data, because it's not absolute track data. It's perception information from the environment carried by an autonomous firefighter. So you're into the terrain of the map is not the terrain, and you're also thinking about models and the imperfection of models. But actually, people are very good at ingesting this. So there's lots of trade-offs and challenges around how you display this information. But there's also a lot of scope for good enough approach. So we began by looking at an IMU-based approach supplemented by RF. So we did accept some degree of uncertainty. This is then combated by the fact that you have multiple agents sampling the world and those units communicating, as well as then parameterizing firefighter movements. You actually had to move away from this somewhat because of IP constraints provided by T-Rex systems. And they've created an amazing sort of inertial profile tracking service. And but that really meant, despite having played with it, and it is an amazing bit of technology, we had to look at a sort of lighter-weight SLAM system. This comes with a lot of benefits. So we very quickly found ROS, adopted into this. It's got a very, very steep learning curve, as I'm sure many of you know, and then pushed towards looking at different SLAM methods. But the real constraint was that cheap, affordable hardware, as well as sensing would actually work in that environment of smoke, high humidity, loss of heat, and not being able to offload any of that heat into the environment really. So a lot of high intensity processing isn't available. So our solution is to look at a couple of different ways, is to assume that one or other of these systems might fail, but interoceptive, when it's supplemented, say, by IMU tracking, if it's supplemented by a pattern, say, of the built environment when it's moving along a wall, for instance, we can then assert certain patterns within that and start to extract a better map than, say, just the IMU on its own could develop. And additionally, you can kind of combat some of the more egregious forms of drift. But really, the goal was to look at a lightweight SLAM solution. So we adopted these, an array of 3 KLD7 millimeter wave modules. And one of the best features they've got is we recognize too that because the sensor has to be chest mounted in our instance, the field of view is going to have a lot of noise in it and already fairly constrained. So a lot of like hands and limbs and various other things. So you wanted to have targeting data that could kind of strip out some of that information, or at least assert, okay, that's a firefighter, or that's a bit of you moving through the field of vision. And I think that, that was very promising, but unfortunately we then ultimately engaged with University of Edinburgh, and despite multiple iterations, we actually had to align to using the AWR boost, which we'd initially dismissed on cost grounds, but very helpfully they kind of showed that there is a pathway there to development. It's just potentially longer than we had available to us. So the other thing that University of Edinburgh brought was a lot of their considerable expertise in MilliEgo that are developed from MilliEgo, which is a lightweight DNN capable of taking millimeter wave data sensed through smoke and other attenuations, combining it with IMU information to create odometry and the location and mapping, so SLAM. The supplemental point to that is the submapping feature. So basically taking that information and generating these global maps by kind of defining these little small groups of maps into a bigger map. And that's a really effective way of doing it. So it runs on a very, very light DNN, typically on some of the NVIDIA sort of Jetson family, but also I think they've had it running on a Pi, but obviously the less resources, there's compromises to how that system works. But we think that's an interesting path ahead. So again, some other work that we've done. So you've now built this map. How do you then get it out? You can't send point cloud information, and some of those submaps don't necessarily encode enough detail in order to kind of contextualize it. So we did an awful lot of work to kind of how we would discretize it, but also what's the kind of minimum detail that a person and a computer need to kind of inform a localization decision. And you can start to then see how we're presenting that inside of Unity. So this kind of very sparse mapping data, this is based on LiDAR information and octamaps. And you can start to then sort of choose what to display and how to display it to give context without needing to display everything. And even kind of trim it down or run other modules to only display, say, the edges of a room or what you perceive to be the boundaries of a compartment. Sorry. Additionally, on the other end of the spectrum, we started looking at, say, like patterns of movement via the IMU, particularly with multiple samples and other indicators. So stairwells is the obvious one because it's a key point of navigation, as well as compartments. So basically, if you, as you're building through the environment, as you're building through the environment, there's different ways of perceiving it. So one is sort of via occupancy, and that can be both via the physical occupancy and effectively, parameters around what they can search, what they've touched, whether they've then sort of moved through what otherwise was thought to be a solid object, and ultimately our sensors are carried, so they're parasitic to some extent about what they can see and when they see it. So there's a lot more uncertainty. And then secondly, so relying actually on some of the firefighters' behaviors is a really positive thing. Second of all, the map on the right-hand side that we're now showing is showing how we're kind of compartmentalizing and grouping some of this data. So actually what I can start to do is to state someone is on a particular level because I've seen a consistent pattern of, say, vertical and horizontal movement and other indicator that lets me then state, okay, display only everyone on level 5, or then to take 2D or 2.5D information and display it on that plane. So whilst it's not perfect SLAM and it's not continuous, not creating this perfect world, it is enough to then kind of group that information, and we think provides some value and meaning. So finally, for our part, our partners at University of Edinburgh are putting together a 30-month-long research proposal. We are proposing to support that, and one part of that is bringing together a consortium of the fire agencies, so both Mid and West Wales, UK Fire and Rescue Service, and Scottish Fire and Rescue Service, as well as some of the other research bodies, to create an advisory body to really support this. So we're very rather convinced they might be onto something, particularly as they're able to introduce thermal inertial odometry, which could be absolutely game changing. So for our part, we're now looking at the kind of maybe on a simpler level is how can we enhance some of the things we found via AI and ML, as well as look at sort of more broader applications to help continue to propel and develop this. So in particular, looking at this discretized world, and we think it's a really good way of looking at the man-made world. And the way that we're going to do that is you've got two agents moving through a world. If it's discretized, you can combine both weighted parameters, like how they move and how far they can move, as well as some of the learned parameters from those onboard DNNs, albeit lightweight. And that gets you a much higher confidence of the perception, and seems like a really good path to the good enough route. So we're actually actively seeking partners and engaging in both the UK and the US. So be very open to conversation and discussion around this. And then finally, this is a kind of snapshot. If I had more time, I'd love to elaborate on this, but I'll happily field more questions afterwards. So thank you again for your time, and I look forward to speaking to you.
Thank you very much, John, for the very, very detailed presentation. I think John and let's say Brandwidth company is a very good example of a RAI company which is operating in this sector. And John has expressed a very strong point here to say that collaboration with university, businesses, investors, funding bodies is really key to solve a lot of challenges which he had. So with that, I will welcome another speaker and the last one, Steve Mcclendon, to also share his own experience in the innovation initiatives which he has been running. All to you, Steve.
Good morning. My name's Steve Mcclendon, and I'm a retired group manager from Mid and West Wales Fire and Rescue Service. And prior to my retirement, I was leading the Transformation 2020 programme, which was looking at digital innovation within the UK Fire and Rescue Service, with particular focus on the operational environment. I'm now retired, and I'm now working as a consultant, but I'm still very much active in the digital innovation field for the UK Fire and Rescue Service and the wider first responder community. So what I'd like to do is to go through my presentation today. I've got a number of focus areas which I'm going to touch upon, but everything that I've been focused on and doing, and what's really exciting for me in relation to the introduction of new technology, and in particular artificial intelligence, is that it's all focused about enhancing firefighter safety. And by enhancing firefighter safety, we can then make sure the outcomes we deliver to the communities we serve are a lot better. So what I hope to do in this short session is go through where artificial intelligence and the emergency responders are, what is AI to most operational firefighters. And when I say firefighters, please read across to the wider first responder community as well. I'm going to talk through the current technology capabilities, because there have been some significant advances from a fire and rescue perspective over the last 3 years. I'm going to talk about some of the emerging capabilities that I've been working on and some of the potential possibilities. And I think it's then really important from an operational perspective to talk about the perceived risks associated with new technology as a whole, and in particular AI. And there are positives there, because AI can also help eliminate some of those risks. And then it's really just touching on briefly what we see the future of AI in emergency response. So I think when you start talking about technology and in particular artificial intelligence, machine learning within the UK Fire Service and the fire service globally, I think you will find that most people will draw back to their knowledge of it, and it is very much linked to the early Terminator films. And there's a perception is that AI is going to take over. So it's important when developing anything related to AI and technology from an operational perspective, that chances are people are going to be very wary of it, or maybe not quite understand it. And I think when you approach things from that perspective, it enables you to have a much better routine, because you're always looking to reassure and make sure that people understand that the AI being implemented is there to help. It's not to take over or replace. So the current technology capabilities which we do have is, we've seen over the last probably 3-4 years the emergence of drones being used in the operational environment. I was really fortunate to lead Mid and West Wales's drone programme, and we've had great success with that. And we've seen the number of UK fire and rescue services and other first responders who are actively using drones now has probably increased tenfold. The capability that it gives us is unprecedented. The views and the insight to the incident, not only during the incident, but obviously post-incident, so we can review and learn, is something which we've never really experienced as readily as we have done recently. Obviously, we did previously have access to police helicopters, but again, they were often quite difficult to get hold of. We're also within the T20 programme, and with some of our partners, we've been exploring the use of real-time streaming body-worn cameras. We've also been developing intelligent incident management and situational platforms, such as Umblr's Iris Core platform, which has been adopted by a number of UK and European fire and rescue services. And we've also been developing the digital infrastructure, which allows all of these systems and sensors to hang off of. And that's where we've been working with our partners in Accelerate to develop the Links Hub and also put 4G Wi-Fi routers with GPS enabled onto our appliances. So this is the technology, which is, I mean, with the exception of the body-worn camera streaming, the other elements, the drones in particular, and the expansion of the 4G Wi-Fi network is becoming more prevalent. The Iris Unblur Core solution is one of the first platforms which actually allows all of this new type of information to surface in one place. So in relation to emerging technology, I've been really fortunate. I've just finished a 2-year GovTech Catalyst project where I worked with 2 outstanding companies, Brandwidth, who would have heard from John earlier on, and also from our other partners, Ox and Grieve, where both of them have done extensive work to really move forward the capabilities of being able to track firefighters and, again, any first responder going into GPS denied environments, which is something for me as a veteran tactical and strategic commander is one of the holy grail tools. It's something that we've always needed and something that organizations like NASA have been working on for 4 or 5 years. So we are getting a lot closer. But again, the key to these technologies working effectively is the artificial intelligence and machine learning, which goes behind that. But through this capability now, outside of a building, during a live incident, I will know where my firefighters are. And likewise, post-incident, we can do some significant learning too. Other technologies which we have been developing is the use of the Zebra HD 4000 heads-up display, and then also we've been experimenting with the Microsoft Hololens too. And this enables us to take traditional 2-dimensional CAD drawings and convert them into 3D interactive building models, which, as you can see from the video, gives us an unprecedented insight. And then if we can overlay other information into that, such as casualty location, firefighter tracking, fire spread, then that's going to be an unprecedented level of situational awareness and risk management, which we're going to have. Other elements that we've been looking in where AI is coming into its own, there's an emergence of a new approach to the way we manage our risk critical assets. And that is through using AI and machine learning to create algorithms which then will intelligently distribute and track operational assets. So this means that where an organization traditionally issues 2 tunics to each person, and therefore 50% of all kit is not available to anybody at any time, then by introducing solutions such as iTrack PPE, it allows you to issue or make available a set for an individual for their dedicated use, but then has a profiled, intelligently managed stock, which allows the overall asset holding to be reduced by up to 50%. And then also the annual revenue costs or turning round of kit or replacement of kit down by up to 70%. What this means is that you actually are, through the artificial intelligence, you're making sure and preempting when kit is going to be needed in places, and therefore it automatically up stocks, and therefore you get a full utilization of the kit. You know, there's a lot of things there, but the artificial intelligence is particularly going to be vital there, because it does the preemptive work by looking at instant stats, weather, news data, profiles, any data source to actually predict where the kit's going to be needed. So when we start to look at emerging technology, one of the things that we have to bear in mind is that especially in the operational environment, it's very dynamic and there is limited time. And when we say limited time, when we've introduced new technology, we've always said it has to be instantly deployable, and instantly deployable is 90 seconds, and it mustn't interfere with what we have to do with running out hose, risk assessing, getting people into their breathing apparatus and started up and making our way in. So what we have started to do is really be cognizant of what the potential risks are with bringing in new technology. Bearing in mind, if we're bringing in now drone images, thermal imaging feeds, body cameras, we're looking at tracking, we've got telemetry data from the breathing apparatus set. So there's all these information sources, not to mention maybe smart buildings starting sending in information on the building, or where the fire spread is, or where movement was last detected, or facial recognition coming in to start recognizing if people have passed somebody with a body camera on, so we know that they are accounted for or not. So there's lots of things that we need to consider, and the things are that there could be information overload. Suddenly we've got all these sensors giving us all these pieces of information which we never had. There may become an over-reliance on technology, where our incident commanders, who are absolutely brilliant at what they do now, but they don't really have a huge amount of technology to help them make their decision-making. If they become dependent on the technology, so they need to have their tracking data, their thermal imaging data, their telemetry, if any of those items are not there, is that then going to cause a byproduct where there's decision paralysis, where previously, before the tech, they would happily make those decisions, and now, because one of those elements is missing, is it going to stop them from doing what their core function is? We also need to understand what the impact of new technology is with the human-machine interface. Is it going to be a distraction? Are people going to get drawn into looking at videos as opposed to glancing, making decisions? Are we going to unintentionally de-skill our people, our decision makers, because they'll become over-reliant on the tech and therefore won't make any decisions unless the computer says yes? And also from the end users and the wider community, if we are using more drones and body cameras and facial recognition and tracking and everything else, is there going to be concerns where people won't act because they feel they're part of the big brother syndrome? So they're concerned that everything they do is being monitored, is going to be challenged, be criticized, or going to be held to account. And I think obviously with anything new and digital, there is always the GDPR and the data reliability. How reliable is the data that we're getting? And again, this is where the AI and machine learning and the development of that needs to be really quite focused to make sure that the data which we get is caveated with, this is the best data which we've got. The final part for me is really, what is the future of artificial intelligence in emergency response? I think, as I said before, there's, with the adoption and introduction of more sensors and data sources, it is without doubt going to make the quality of the decision making a lot better, because they're going to have more information and a shared situational awareness for all involved. And that is definitely going to be an asset to assisting in decision making and post-incident learning. I think we need to, and this is where the AI comes in, with all this information coming in, there is a real need for the AI to be able to declutter, to be able to draw out the most prevalent and specific data, which can be surfaced in a way that allows the incident commander to understand it and then act upon it in a timely and effective way. And I think, again, this is where we talk about trying to get the general noise taken out and then just really being able to focus on the risk critical elements. I think finally for me, the really important thing, and this is a really specific to the fire and rescue service, the UK Fire Service is absolutely brilliant at adopting new things, but they have to do it in their own time and in their own way, and they've got to have the reassurances the whole way through. And I think the most important thing is that we need to make sure, whenever we talk about technology and artificial intelligence in particular, is we caveat it, or we provide the reassurances that it must only be used as a tool to assist. So when we talk about it, it's there to assist you as the human being in making decisions, because I think at all costs we have to avoid the unintended perception that we may end up into a situation like the Terminator films, when Cyberdyne Technologies, Skynet, suddenly becomes self-aware and takes over. So that's a really whistle-stop tour of how I see artificial intelligence and new technologies coming into the UK Fire and Rescue Service, where we currently are and where we're going. So thank you.
Thank you very much, Steve, for sharing your experience. And it's really, really important to understand that when Steve has, with Steve's presentation, is trying to tell us that there's huge appetite in adopting technologies in first responder services. And also, he has clearly demonstrated how they are trying to work hard to achieve this. But he also helped us to understand which issues to consider when developing these technologies, which is really good help for those who are interested from our RAI community, for them to understand where to start. So all our speakers shared challenges, but these challenges are a great opportunity for robotics and AI community, as well as research community as well. We need to realize that the first responder sector is in high demand, not only in this country, but in the whole world. We have seen huge problems. Only last year, we had COVID, we had floods, wars, earthquake, we had train derailed, we had fires, we had political unrest. These problems are not going to disappear. They are going to be there for a very long time. And these opportunities are not going to come on their own. We just need to work together to build these technologies, not only for the UK market, but also for the international market. So with that, thank you so much for all the speakers who have contributed in this session. And I will now bring this session to a close, but I will urge you to go to the collaborative session, which is going to start immediately after this session. Thank you very much for attending, and thank you very much for all those who contributed in this session.